Now let's look at a bigger K-map. It's a 5-input Karnaugh map, and this is usually the biggest that we're going to deal with. Just because once you get up to 6 or more than that, once you get up to 7, you're into 4-dimensional K-maps, and that's a good way to melt your mind on a Friday evening, so let's not do that. Let's focus on this 5-input K-map. So we're given our function in the shorthand SOP form. And so usually what you want to do is label our cells. But before we even do that, let's label our axes. So what do we got here? We've got 5 variables. And actually, the way that we do our K-map is our most hierarchical axis is this K-map is on top of this K-map, meaning that like this corner is touching this corner here, this corner is this one, right? They're floating over top of one another. And so that means we kind of have this z-axis going on here, where if we were to go up from this cell, we would end up in this cell. And so that's what we're going to call our most significant axis, or in this case, our a-axis. So we're going to say, if we're here, a equals 0. If we're here, a equals 1. And now the rest of our variables just kind of fall into place like normal. We've got B, C, D, E, and the same thing is here, right? B, C, D, E. And let me just label our numbers like normal. We've got 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, and 1, 0. And just as a quick reminder, just in case you've gone through all these examples and you didn't catch it, I'll remind you again that this means that the leftmost bit on this axis represents B, and this one represents C. That means that this is D, and this is E, and then here this means A. Everything in here A equals 0, and everything in here A equals 1. So A is constant here, and A is constant here. All right. Now for this last step, what I want to do is I want to label all of these cells. And so right here, this cell, we know that we've got A equals 0, B, C, D, and E all equal 0, so that means that this cell must be 0. And as it turns out, this the structure, how we go doot 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 doot, kind of bounce around here, stays the same. We just do A0 and then A1. So I can just go through and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then we bounce over and we start off at this point again at 16. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. All right, and now we can just get to filling things out. So I'm just going to put just the 1s in, and that's what our sum of products form is telling us, is where our 1s are at. So that means we've got a 1 here, 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 at 4 and 5 and 11 and 15 and 27 and 31. So that's where all our 1s are at. Now we can start circling our implicants. So let's just start with this little 1 here and start growing things. So we see that this one, right, could get circled as an implicant, but we've got room to grow, right? It could grow here, and then it could grow here. And we got to be careful with their 5 input because we know that it could also grow downwards as well, or upwards, whatever way you want to see it. But these are all zeros, so that means it couldn't grow in this direction. So that means that implicant is as big as it's going to get, or it's a prime implicant. Let's look at this guy here. We can start by circling this, and then we could say, hey, can this grow anywhere else? Oh, I don't think. Oh, wait, it can, right? It can grow across this side, right? These edges still are connected. So that means we've got a connection here and here. Now let's look at this one here. We could circle that one, but we know it could grow. And then let's not forget that we need to see if we can grow in our third axis, or in this case, we could kind of call it our A axis. And lo and behold, we can actually grow and collect these ones as well. So kind of the way I notate that is I circle this, and then that's why 5 inputs can get very messy, but I kind of do this dashed line to indicate that they're connected there, or this is an implicant of 4. Now let's circle our prime implicants because we got everything covered. And we see, or not prime implicants, but our distinguished 1 cells. And we see that all these guys are actually distinguished 1s. And that's a distinguished 1. So that means all these are essential prime implicants. So now for our final step, let's find out what function or what term represents these implicants. So let's look at this big guy first. It looks like, first, we know it's in the A plane, or the A map, where A equals 0. So that means A is a constant because it doesn't go into this one as well. So that means our first term, and I'm just going to draw them all down here. Oops, I don't want that color. Maybe darker. So we've got A naught, right, because A is a 0. And let's see what else stays the same. Looks like B stays as a 0. C changes. D stays as a 0, so we got D naught. And E changes. So this is A, B, D. Or A naught, B naught, D naught. Now let's look at this, consider this smaller term. And it's all in the A plane, so that means we're still going to have A naught. B and C are staying the same, and they're both zeros. So we got B naught, C naught. And it looks like E also stays the same as a 0, so we've got E naught as well. And finally, let's take a look at this guy here, this prime implicant, or essential prime implicant, we should say. So it looks like A changes, right? A is a 0 here, and A is a 1 here. So that means A does not make it in this term, right? It gets factored out. But it looks like B stays the same, right? So we've got B, right? We got to make sure we check. You could say we got to check all these, but we know that if it stays the same here, it also stays the same here. So that means B stays as a constant 1. It looks like C changes from a 1 to a 0. And then here, it looks like we've got D stays as a constant 1, and E stays as a constant 1. And let's finish this off by just saying X equals. And there we go. So that's our 5-input Karnaugh map. It is a little bit more difficult, but not much more difficult or unfamiliar compared to the 4 inputs.